The abyss awaits discovery and science of undersea vents. A light in the darkness. Imagine a place on Earth so deep, so dark, that sunlight has never touched it. A world beneath the waves, where crushing pressure presses down like an unstoppable force, and temperatures can change from freezing cold to boiling hot in the blink of an eye. Yet in this place, this extreme alien world, life not only survives, it thrives. Welcome to the hidden universe of hydrothermal vents. These extraordinary cracks in the ocean floor belch out mineral-rich superheated water, creating oases of life where none should exist. But what powers these mysterious ecosystems? How do creatures survive where no light reaches? And what might these vents reveal about the origins of life itself, or even the possibility of life beyond our planet? An ocean of mystery. For centuries, the ocean was a vast unknown, a silent, dark expanse hiding more mysteries than any other place on Earth. Humans have explored space, climbed mountains, and even mapped the surface of the moon. But when it comes to the deep ocean floor, less than 20% has been explored. The depths remained a frontier of mystery, a place assumed barren and lifeless. Before 1977, scientists believed that the deep ocean floor was a cold, empty desert. No light, no food, no life. It was an environment so hostile, the idea of ecosystems there seemed impossible. But everything changed during a groundbreaking expedition in 1977, when a small research submarine called Alvin made a descent into the darkness near the Galapagos Rift. What the crew found shocked the world. The discovery that changed everything. The year was 1977. Scientists aboard the Alvin submarine were sent to explore the mid-ocean ridge near the Galapagos Islands, an area where tectonic plates are pulling apart beneath the sea. They expected to find a barren, rocky seafloor. Instead, what greeted them was a bustling ecosystem unlike anything ever seen. Entire communities of life clustered around plumes of superheated water shooting from cracks in the ocean floor. Gigantic tube worms, some over 2 meters long, stood like alien towers. Crabs and shrimp scuttled across the rocky terrain. Strange clams and other creatures clustered tightly around the vents, thriving in the total absence of sunlight. This discovery shattered the long-held scientific belief that all life on Earth depended on sunlight and photosynthesis. Here, deep beneath the waves, life found a new source of energy, chemicals released from the Earth's interior. The discovery of hydrothermal vents rewrote the biology textbooks and opened a new frontier in our understanding of life on Earth. How hydrothermal vents work. The science beneath the mystery. To understand these strange ecosystems, we first need to dive into the science of how hydrothermal vents form. The Earth's crust is made up of tectonic plates, massive slabs of rock slowly shifting over the molten mantle beneath. At mid-ocean ridges, these plates pull apart, creating fissures and cracks in the seafloor. Seawater seeps down into these cracks, plunging kilometers beneath the surface, where it encounters magma heated to over 1,300 degrees Celsius. This intense heat transforms the water into a superheated, mineral-rich fluid reaching temperatures over 350 degrees Celsius, hot enough to melt lead. The superheated water then bursts back out through the ocean floor cracks, creating towering plumes of black or white smoke-like mineral particles. These are the famous black smoker and white smoker vents. Unlike the steam you see boiling at home, this smoke is actually tiny mineral particles, rich in metals like iron, copper, and sulfur. The vent fluids are acidic and toxic to most forms of life, but they provide the essential chemicals for the unique ecosystems surrounding the vents. At the heart of these ecosystems are microbes that perform chemosynthesis, a process that uses chemical energy rather than sunlight to create organic matter. These bacteria oxidize hydrogen sulfide and other chemicals in the vent fluids, producing energy that supports not just themselves, but entire communities of organisms. In essence, hydrothermal vents form oases of life powered by the Earth's inner heat, independent from the sun's energy. Alien life forms and scientific wonders of hydrothermal vents. Creatures of fire and darkness. Beneath the ocean's crushing depths, where no sunlight penetrates, life flourishes in a dazzling array of forms. Creatures so strange they might be mistaken for visitors from another world. At the heart of these ecosystems lie the giant tube worms, towering sentinels reaching lengths of over 2 meters, anchored firmly to the rocky seafloor. These creatures have no mouth, no stomach, no digestive tract as we know it. Instead, their lifeblood is a remarkable partnership with microscopic bacteria living inside their bodies. These bacteria perform chemosynthesis, converting the toxic chemicals spewing from the vents into nutrients the worms need to survive. Imagine a living organism that depends entirely on the invisible work of bacteria to feed it, a perfect symbol of cooperation in this hostile realm. Nearby, the yeti crab scuttles across the seafloor. Covered in thick white hair-like structures on its claws, the yeti crab cultivates colonies of bacteria, which it then harvests for food, farming life in the abyss. It's a startling example of evolution's creative solutions to life's challenges. The Pompeii worm, one of the most heat-tolerant animals on Earth, thrives right at the edge of the vent's superheated water. Wrapped in dense bacterial mats, it survives temperatures up to 80 degrees Celsius, almost hot enough to boil an egg. In this underwater inferno, life finds a way not only to survive, but to flourish in unimaginable conditions. Even the vent shrimp have evolved extraordinary features. Their eyes are located on stalks on their backs, allowing them to detect heat rather than light, perfectly adapted to their pitch-black, fiery surroundings. These creatures represent a class of extremophiles, life forms that thrive where others perish, challenging our understanding of biology and expanding the definition of habitable environments. Hydrothermal vents beyond Earth hour. Fascination with hydrothermal vents goes beyond Earth's oceans. The conditions at vents hint at the possibility of similar ecosystems existing on other worlds. Take Europa, a moon of Jupiter, and Enceladus orbiting Saturn. Both are icy moons believed to harbor vast subsurface oceans beneath their frozen crusts. Recent space missions have detected plumes of water vapor erupting from Enceladus, suggesting hydrothermal activity similar to Earth's vents. If hydrothermal vents power life here, Could similar vents beneath these alien oceans harbor life too? Could these icy worlds be home to ecosystems like those we've discovered deep in our own seas? The search for life beyond Earth has expanded from distant stars to these hidden ocean worlds, and hydrothermal vents have become a guiding light in that quest. Why hydrothermal vents matter. Lessons for science and humanity. Hydrothermal vents are more than scientific curiosities. They are natural laboratories offering profound insights into life's origins and resilience. Many researchers believe that life on Earth might have begun near hydrothermal vents around 4 billion years ago. The combination of chemical energy, minerals, and warm water created a crucible for life's building blocks. Studying extremophiles, life forms thriving in harsh conditions, helps scientists understand how life adapts to extremes, providing clues about the limits of biology. But the impact of vents extends beyond biology. The unique enzymes found in vent microbes, capable of functioning under extreme heat and pressure, have inspired advances in biotechnology and medicine. These heat-stable enzymes are used in industrial processes and hold promise for developing new pharmaceuticals. Furthermore, vents play a role in Earth's carbon cycle, cycling chemicals between the crust and ocean, influencing climate and global geochemical processes. Hydrothermal vents are windows into Earth's deep past and keys to our future. Threats, conservation, and the future of hydrothermal vent. Exploration, threats beneath the waves. The deep sea. At risk. While hydrothermal vents have remained hidden in Earth's abyss for millions of years, they now face unprecedented threats, not from nature, but from humans. The growing demand for rare minerals such as cobalt, copper, and rare earth elements has pushed deep-sea mining to the forefront of industrial ambitions. These minerals, vital for smartphones, electric vehicles, and renewable energy technologies, are abundant near hydrothermal vents in the form of metal-rich sulfide deposits. But mining these fragile environments is fraught with peril. The ecosystems that depend on vents are extremely delicate, evolved over millennia in isolation. Disturbing the seafloor with heavy machinery risks destroying entire communities, potentially wiping out species unknown to science before we even have a chance to study them. Currently, the deep ocean lacks comprehensive legal protection. International waters remain a regulatory gray area, with slow-moving governance struggling to keep pace with technological advances. The question looms: can humanity balance its insatiable hunger for resources with the stewardship of these irreplaceable underwater worlds? Protecting the abyss. Thankfully, scientists, environmentalists, and international bodies are raising the alarm. Efforts are underway to establish marine protected areas around key hydrothermal vent fields, preserving biodiversity and ecosystem functions. Organizations such as the International Seabed Authority are beginning to draft guidelines and regulations aimed at sustainable management of deep-sea resources. Public awareness campaigns emphasize the intrinsic value of vents, not just for their unique ecosystems, but for their contributions to science, medicine, and even the future of life beyond Earth. The future of exploration, into the unknown. The ocean's deepest mysteries beckon new generations of explorers and scientists. Advancements in technology are revolutionizing our ability to map and study the deep sea. Autonomous underwater vehicles, AUVs, equipped with AI, can now navigate the crushing depths for months, sending back detailed images and data. NASA and other space agencies plan missions to icy moons like Europa and Enceladus, aiming to detect signs of hydrothermal activity and potential life. Meanwhile, next-generation submersibles are pushing deeper and longer than ever before, allowing humans to witness firsthand the wonders of hydrothermal vents. The quest to understand these alien-like worlds is only just beginning. The abyss calls. Hydrothermal vents remind us that life is resilient beyond imagination, finding a way where none seemed possible. These glowing chimneys of fire and life are not merely cracks in the Earth's crust. They are gateways to understanding our origins, our future, and perhaps the universe itself. The abyss calls to us, inviting curiosity, caution, and awe. Its secrets are vast, its ecosystems fragile. Our responsibility is clear: to explore with respect, to protect with passion, and to never stop searching for the unknown. If you enjoyed this deep dive into the mysterious world of undersea vents, don't forget to subscribe and share this video with fellow explorers. Stay connected and keep following our journey as we uncover more incredible secrets from the depths of our planet and beyond. Thanks for watching, and see you in the next adventure.